Just wanted to reinforce some concepts that we were trying to finish up. We talked about it in both sections on Friday, but I don't think this is one that could ever have too many resources to help with. So here I have a sequence, and it's being defined through a sum. That means that this Sn is the accumulation sequence. This formula, k minus 20 times k minus 30, that's the formula for the increments. Those are the numbers that are added one at a time to create Sn. And if I gave that a name, let's say xn, what that means is, here n is my index, n minus 20 times n minus 30 is the last number. That's what I get using the last index. It's the last number added in the series to be able to create the value Sn. So as long as this is positive, I'm going to be adding positive numbers to my sequence Sn, and it's going to be getting bigger. It's going to be increasing. When xn, the increment, is decreasing, that allows me to know when this sequence, if xn is negative, I'll be subtracting numbers, and this Sn sequence will be getting smaller. So xn is the same as the backward difference for Sn. The thing is, we don't have a formula right now for Sn, although we do know a way to find a formula. That's not part of the question. So we could find an explicit formula if we used summation formulas, so using accumulation formulas. Now, I could actually do that. Now, an important point, notice that this formula right now is a product. Summation does not split over a product, and so I would need to expand that. I would write Sn happens to be equal to a sum. I would need to multiply this out, so k squared minus 30 minus 20 is minus 50k plus 600. Here's a different formula for my increments. This is already factored. I was trying to save time. This is the unfactored version, and this is a sum, and so I could split this up into three pieces. I could be adding k squared. We know an accumulation formula for that. I could subtract 50 times what happens if I sum k. This is an increment sequence that I have an explicit formula for. And I could add 600 sum, don't forget that there's a 1. And I could finish by using my summation formulas. Sn is some formula, because this is the sum from 1 to n. I just use the accumulation formula. Minus 50n times n plus 1 over 2 plus 600n. Notice this is an explicit formula. I could multiply that whole thing out and I get a formula. If I were to take the backward difference and do Sn minus 1 and simplify it, this is the backward difference, I would recover n squared minus 50n plus 600, because these are the increments. So using accumulation formulas and finding backward differences, those are inverses of one another. And so when I have a summation representation of a sequence, I don't need to do the backward difference. I have the backward difference. All right, now that I have my increment, I could do sign analysis on the increments. So here is my index and my increment, which is the same as xn. And I have at 20 and 30, my increments are 0. I could pick numbers like 0 is less than 20 and 30. So negative 20, negative 30, that makes it positive. 25, that'll be positive and negative. And 35, that's positive, that's positive. And so I have sign analysis for my increments. What this means is that my increment for s, the numbers that I'm adding, are positive. For my index values, increments, so my sequence s, the first increment is at k equals 1. And so my increments start at 1. And until 19, I have positive increments. And it's 0 at 20, and then it's negative for n going from 21 to 29. And then it's positive again for n going from 31 forever. Okay? Having my increments, knowing if I'm adding positive or negative values, tells me that my sequence, the sequence that's found by adding these up, is going to be increasing. All right? Because my first increment is added to the 0 element of Sn, my first value of s is at n equals 0. I'm increasing from 0 to 19. And then I'm going to be decreasing for n going from 20 to 29. And I'll be increasing for n going from 30 forever after. Okay, so this gives me my increasing and decreasing. What else would I want to do? I would want to know about concavity. Well, concavity is about where the increments are increasing or decreasing. So as I add these numbers, I need to know if the next number I add is bigger than the previous number I added, or if it's smaller. And if these numbers are getting bigger, if these are increasing, then I'm going to be concave up. If these numbers I'm adding are getting smaller, if they're decreasing, I'll be concave down. And the way that I'm going to do that is I'm going to calculate the increments of the increments. So these are the increments of the increments, the second backward difference. And the way that I do that is I calculate xn minus xn minus 1. Because I have an explicit formula for my sequence, I have to calculate the backward difference. For Sn, because I had it as a summation, I knew the increments. Here I have a formula for my increments xn. I need to calculate a formula for the previous increment, so we're going to do a little algebra. Every n gets substituted by n minus 1. And now I have to expand this, and you should be pretty good at expanding that. It's always the same formula. Minus 50n plus 50 plus 600. And when I subtract this formula minus this formula, I'm going to have n squared minus n squared. Those cancel. Minus 50n minus minus 50n, those are going to cancel. And the 600s cancel. And all I'm left with is subtracting these terms right here. So I'm left with minus subtract negative 2n, 51, so subtract 51. This is a formula for the increments of the increments. And I can do sign analysis. Here's my index, the increments of my increments. This is equal to 0 when n equals 51 over 2, which is the same as 25.5. And so the first increment, first index is 26 above and 25 below. If I put 26 in, I get positive values. If I put 25 in, I get negative values. And so I now have information about my increments. My increment for xn is negative. And remember, the first value of n is n equals 1. My increment of this sequence starts at 2. So I'm negative for n goes from 2 to 25. I'm positive n goes from 26 forever. And so this tells me that the increments are decreasing, and I go back 1, from 1 to 25, and increasing, n goes from 25 to infinity. And now that I know that my increments are decreasing and increasing, this tells me that my sequence is concave down. Again, we go backwards 1 from an increment to a sequence from 0 to 25, and I'm concave up. N goes from 24, that's 1 before 25, forever after. All right, well, there's one more thing that we can do to reinforce some concepts. I have some information about my sequence. It's increasing, decreasing, increasing. It's concave down and concave up. And what I want to do is I want to make a connection to the things we did earlier with functions, where we could take information about the shape and use that to be able to understand the graph. So we're going to temporarily pretend that this sequence is really a function, and this is what we have describing my function. These intervals are really describing my domain. So if I have a graph, I start at 0, and my behavior has these key changes happening at 19 and 20. And a regular function would be a single point. At 24, 25, and at 29, 30. So again, for functions, these would collapse to a single point. There's no such thing as a previous value. And so on this first piece, I'm increasing in concave down. And so my behavior of my sequence is increasing in concave down. And the reason it's concave down is the increment that I'm going up by is decreasing. Now, from 19 to 29, from 20 to 29, I'm now decreasing, but only until 25 am I still concave down. So I'm going to be, come on, pen, decreasing, and then at 24 it switches to concave up, but it's still decreasing, and then I start to increase again while concave up, and so my graph is going to look like that. What that means is my sequence, which by the way at 0 is 0 because there's no initial value, it's S0 must be 0. I'm going to be increasing as a sequence, but I'm going to be concave down. And when I reach the value of 19, so here's 19, say, 19 and 20 are the same height because my increment, my 20th increment was 0. And then it's going to start to decrease, but it's still concave down. And then at 24, compared to 25, it starts to switch. And my concavity starts to switch. So that I'm now concave down, I've switched to concave up. My sequence is going to, at 30, 29 and 30, they're the same height, and then I just go up. And so I have an increasing concave down reaching a maximum, decreasing, there's an inflection point, reaches a minimum, and then it goes up forever. And so I have a shape found by putting these pieces of information together.